Good afternoon, everyone. My name is Charlie Hamer. I'm one of the co-founders of the Public Sector Network, and thanks for joining us for our webinar in partnership with AC3. Today's webinar will be around how containerisation can unlock the power of infrastructure as a service. We'll be holding a short Q&A at the end of the webinar, so for those using the online tool, please feel free to send us your questions in the question box on the right-hand side of the webinar tool, and we'll do our best to cover those at the end of the session. So thank you once again, and that's enough from myself. And let me pass you across today to Brian Carrera from AC3, who will kick things off.
Hi audience, thank you for joining and welcome to the AC3 Bulletproof Webinar Technology Series this afternoon. Our first webinar is entitled, How Containerisation Can Unlock the Power of Infrastructure as a Service. Please note that throughout the presentation, feel free to post questions which we'll answer towards the end of the presentation. My name is Brian Carrera and I lead the AC3 Public Sector business in Australia. I want to introduce my two cohorts today. Firstly, Greg Coburn, who is the Chief Cloud Officer at Bulletproof Group Limited, an inspirational leader and pioneer of Bulletproof digital and DevOps practice, having been with the company for over 5 years. Greg has led the deployment of many leading solutions for Bulletproof, playing a key role in the development of New South Wales spatial services, cadastral management, and Movember international charity and sponsorship platforms. It is also my great pleasure to introduce Rahul Duda, Product Director at Service New South Wales, who has been a customer of AC3 in various guises over a number of years. Rahul has been at the forefront of digital innovation in New South Wales Government and for many years the technical driving force behind the New South Wales platform known as OneGov. Rahul led the development of the first digital driver's licence in Australia, initially deployed as a successful testbed in Dubbo, but soon to be rolled out across the state and maybe even Australia, Rahul. In this webinar today, we're going to dig into the technology attic and take you on a journey from the physical to the virtual. You all remember the promise of service-oriented architecture, or SOA. Is it still relevant? We will then move to the land of containers and microservices. Greg will cover the principles and the technical apparatus used, following which Rahul will bring some real-world examples of microservices, which he has used as a practitioner to drive business value. At this point, I'd like to hand over to Greg. And as we are both Kiwis, implore you, Greg, not to mention the All Blacks and the Bledisloe Cup during your presentation, if you can help it. Over to you, Greg.
Thanks, Brian, and I'll try not to mention the rugby too much during the presentation. All right, thanks everyone for joining us today to discuss containers. My name is Greg Coburn. I'm the Chief Cloud Officer at Bulletproof. Feel free to follow me on Twitter, GitHub, and LinkedIn for any future information on containers or any other interesting digital information out there at the moment. I'm going to take you on a journey and a small history lesson. The idea of containerisation isn't new, and we've been thinking in this way for many years. Sometime not too far back, we had hardware that would run a specific application, probably some sort of accounting application or maybe something to do with calculating missile trajectories. These machines were born out of necessity during World War II. They would fill whole floors and were only capable of a few operations per second. They often didn't work in the style computers did today with binary bits and bytes, but this is where the standards were started to evolve. These things were slow and power hungry. Then some smart people figured out how to run multiple apps on the one piece of hardware using an operating system that could slice up time on the CPU and memory. We had the likes of the IBM OS 390, later Multics, and ultimately Unix. Two key people, Ken Thompson and Dennis Ritchie, were responsible for Unix, which revolutionized how we used still fairly large machines. This was the first way of containerizing systems. The operating system separated processes into logical units of work that could share machine resources and operating system resources, and could mean more than one task could now run on a machine, and more than one person could connect to these machines, probably over some form of serial terminal. They were still slow by today's standards, but we're now starting to use standards we see today, and several could now fit into one floor. With the advent of Unix and similar systems, it was now possible to run more than one application on a computer at a time. These applications or processes had some isolation from each other. It was now possible to fit more than one computer into a data center with multiple people accessing the same computer system remotely, e.g. from their office desk via a serial terminal. Not long after that, we had the likes of Sun Microsystems, HP, Compaq, Intel, IBM, and Apple Computer bringing out commodity hardware. This flipped things again. We were back to running a specific application at a time on this dedicated piece of hardware. Depending on the operating system, this could be literally a single application, e.g. on a DOS or Apple-based machine, or for something like HPUX or Sonos, later Solaris, one larger application and maybe a few smaller supporting applications, as these operating systems were Unix-based. If you think about that carefully, you realize that we went full circle. We started off running a big machine on a whole floor with one application. We then invented Unix and ran this on slightly smaller machines, but had many people running several applications connecting via serial terminals. We're now at a point where we were containerizing a whole computer system. This was our container of the day, a system we could slide in and out of a rack, and we could potentially pack hundreds of these into a data center. Now that we were packing hundreds of commoditized hardware into a data center and Moore's law was working its magic, we started to see that we had underutilized hardware. This is when we started to see the likes of x86 virtualization start to become popular, with the incumbent vendor, VMware, becoming a popular choice for businesses worldwide. Another popular open source choice was Xen. As a side note, there was much virtualization before this on many platforms in all sorts of ways. LDOMs, LPARs, and domains, to name but a few. These were hardware and vendor specific, and nowhere near as popular as x86 virtualization. We've done the next layer of containerizing and have created a kind of Russian doll thing, with little virtualized operating systems running on top of a host OS, running on a little computer system that is packed into a rack that is packed into a data center. We've been containerizing in some form for a while, really, and we now had good application isolation by only running a single application, maybe with little supporting applications or processes, in a single operating system instance. This was called a virtual machine. We still have lots and lots of operating systems all over the place to look after, and we're still trying to build large complex systems for high availability. What happens when something goes wrong? With all these operating system instances running as single entities, running one major application, what happens when something breaks? What happens when hardware fails? What happens when network fails? To solve this problem came clustering of virtual machines. VMware vSphere was again the incumbent, but we also saw the likes of Xen Server and Oracle VM with solutions. These technologies made making non-HA applications almost highly available, or at least pseudo self-healing. We've been talking a lot about operating systems and computers, or the emulation and virtualization of those. Let's discuss some applications. A traditional enterprise might look like a service-oriented architecture, or SOA, consisting of several in-house and off-the-shelf applications that all need to talk to each other. They all will likely have different release schedules and requirements. There will generally be an enterprise service bus, ESB, that all these applications will chat on. The applications, while doing a specific high-level task, probably take care of many little tasks internally, often with duplicates. They are likely written in Java and will be large, complex, monolithic, and difficult to deploy, often requiring a very coordinated effort. They are also very difficult to scale as single entities. Let's go over where we're at. We have all these applications. They are big, clunky monoliths. They most likely are talking on some sort of ESB, Enterprise Service Bus. They are complex to deploy, requiring a coordinated effort, often shepherded by one team. They run on a full operating system, which is a virtual machine running in vSphere, on some hardware, all tightly packed into a rack, all tightly packed into a data center. We need a revolution. We need to be able to get to the market faster. We need to be able to deploy smaller units of work. Teams need to be able to work on specialized, task-specific services. Multiple teams want to be able to deploy independently. We need an evolution or a revolution. This brings us on to microservices and RESTful interfaces. Instead of having slow-running, hard-to-deploy monoliths, we want to get to instant gratification. We need services to be scaled and built independently. One of the most important differences between microservices over service-oriented architecture is the granularity of functionality and scope for a given service. Where a single service-oriented architecture service component might perform several operations in a single package, a microservice architecture may bring this up into dozens of individual and tiny service components. To run and deploy these microservices, we need containers. Containers can run atop your existing guest operating systems, e.g. VMware or hardware, etc. So what are containers? Containers are able to provide a logical separation within the kernel of process space and to some degree resources such as memory, CPU, and I/O. They were popularized by Google and provide a consistent runtime environment for your application to run in. Containers are easily deployed across all environments, from your laptop, testing, UAT, all the way through to production, can run on bare metal, VMware, and in public cloud. A container image is very lightweight, containing only the necessary components to run that specific application. Lastly, containers share a kernel with the underlying host OS, which make them really fast to boot. Quoting from Google, from Gmail to YouTube to search, everything at Google runs in containers. Containerization allows our development teams to move fast, deploy software efficiently, and operate at an unprecedented scale. Each week we start over 2 billion containers. We've learned a lot about running containerized workloads in production over the last decade, and we've shared this knowledge with the community along the way. From the early days of contributing C groups to the Linux kernel, to taking designs from our internal tools and open sourcing them, such as with the Kurbenetes project. Let's go over some of the differences between what a container is and what a virtual machine is. Containers are an abstraction at the app layer that packages code and dependencies together. Multiple containers can run on the same machine and share the operating system kernel with other containers. Each is running as an isolated process in user space. Containers take up less space than virtual machines. Container images are typically tens of megabytes in size and start almost instantly. Virtual machines are an abstraction of physical hardware, turning one server into many. The hypervisor allows multiple VMs to run on a single machine. Each VM includes a full copy of an operating system, one or more apps, necessary binaries, and libraries. Taking up tens of gigabytes, VMs also can take a long time to boot. Containers were popularized by Docker, now known as Moby, in an effort to separate Docker the company from Docker the container platform. Docker provides a convenient way to manage the life cycle of your containers. Docker helps you to build images, push them to registries, pull them down from registries, and ultimately run them. So, how do you build a Docker image? You need to use a Docker file. This is an example Docker file that deploys an open source Python application from Pinterest called SnapPass. First off, we start from an existing image that is a specific version of Python. We then define an app.dir of user source SnapPass, of which we are going to install and run the application from. Remember, all these changes are being made within the container image itself. Next, we want to make sure that we're not running as root, so we create a group and user for the application to run as, and also actually create the application dir, where we will put the source code into. Next, we define the work dir, where the application will be stored and run from. Next, we go and copy all of the source from the current directory into this directory so that it can run from here. Next, we run a command to install all the libraries and dependencies for SnapPass the application. We then ensure that it is owned by the right user and group. In the last section, we define a user called SnapPass, which is a reference to the earlier user we created. This will make sure that the application runs as this user. We define a default port of 5000 for a Flask application, and then we define what command we want the application to start as, in this case, SnapPass. What's the ultimate Docker file, I hear you ask? Thinking about a compiled static binary written in something like Golang, you have no requirement of any operating system components, and thus you can use the from scratch starting point and not from an existing image. Therefore, you have no baggage coming along with your container image. This provides us with the smallest attack vector. If we now also mount this container as read-only at runtime, and why wouldn't you, it's going to be very hard for people to infiltrate systems via your application. So now we've got all these containers, now we've got all of these microservices running in all these little deployable units called containers. How do we manage all these? We need to consider ingress, egress, access control, scaling, logical isolation. We need an orchestration tool. This is where the likes of something like Kurbenetes will help. Let's recap. Containers and Docker provide a single deployable unit which can be deployed from anywhere. Your laptop, testing, UAT, and into the staging environment, all the way through to production. It's the same artifact all the way through. Because of the fast boot time, they can also be scaled out very quickly to meet immediate demand. It removes the patching requirements on many running environments as you bring this into the container build pipeline. Containers reduce security risks as you only have the one application running and very few operating system components. Now, I would love to introduce Raul, who will take us through how ServiceNow uses microservices, containers, and Kubernetes to solve real-world problems. Hi, Raul.
Thank you, Greg. That was really fascinating. I just love the way you explained the history of computing in 15 minutes. That was amazing. And thank you very much. I think for a lot of us, we have been through this journey. And I'll talk a little bit about our journey in New South Wales government. Hi, everyone. My name is Rahul Datta, and I'm a product director for Service New South Wales. I've spent a lot of time in the past 15 years working in various roles within New South Wales government, and have been very, very fortunate to work in some really exciting digital programs, and I'll talk about some of them as we speak. So just by way of background, I've spent the last 15-20 years developing applications, running teams, deploying digital, and I've seen the industry move, from physical to virtual to containers, and along the way, in the recent past, when we moved into containers and microservices, we realized that there were a lot of problems that we were wanted to solve. So today I wanted to talk about the problems that we solved using containers, microservices, the kind of solutions that we put together, and the lessons that we learned along the journey. So that's really the summary of what I'm going to talk about. So in terms of the kind of work my team and I did in my previous roles within the South Wales government, so we delivered a whole heap of digital programs, and some of which you might be familiar with. Greg mentions digital license. We also worked on programs like Fuel Check, which provides users access to cheap petrol prices. Feedback Assist, that allows any citizen to provide feedback to government through any website. A whole heap of digital, applications across, various New South Wales government organizations, licensing, payments, etc., and also built something called API New South Wales that allows citizens, businesses to integrate the applications with New South Wales government. So that is kind of the application space that we've been operating for a few years now. So what are the problems that we've basically found while undergoing this journey? So OneGov manages hundreds of digital applications that are deployed on thousands of virtual machines. So the way they were deployed were within the two government data centers on OpenStack private cloud, over a period of time, it was getting very difficult to not only manage, but also to patch, secure, and operate these virtual machines. It was also a struggle to keep up and very, very expensive to manage. So our patching was non-stop, 24/7, and it literally felt like a hamster wheel, and it still does. The other issue is that of monolithic applications, which Greg touched upon. So the monolithic nature of our applications meant it was almost impossible to push out a single feature without having to test the entire application. Application isolation. Many applications share the same web servers, virtual machines, making it very hard to deploy code to production without downtime and affecting each other. Testing complexity. Because the deployments are so complex, it also meant that a lot of regression testing was required every time a feature was released. Automation, deployment automation was a huge challenge, and it's been very challenging to do, blue-green deployments or canary releases, the stuff that modern digital organizations kind of take for granted or is second nature. It was very, very hard. Availability. Because of all these difficulties, it was extremely hard to deploy to production without compromising availability of services. You'd always have to bring down a service, and while you're doing a deployment, and that is kind of the norm, but it is a problem, and sometimes not a very feasible thing to do when you have 24/7 availability requirements. Scalability problems. The VM-based approach meant it was not easy to scale services without cloning an entire VM and using up lots of expensive resources. Auto-scaling was, to be honest, very, very difficult. If one part of an application or a feature in an application was in high demand, we pretty much have to scale the entire application up to meet that demand and not just that feature. So that was one of the other issues. The other context we had was we wanted to make sure that we could run our workloads across multiple data centers, but also have the option to port these services to the cloud easily. So that was also a very difficult challenge with virtual machines, the big virtual machines running lots of applications, because it requires careful orchestration, and it's very, very hard to do. I also want to talk about the security burden. So the sheer number of monolithic applications also means that each application is designed a little bit differently. So overall, the responsibility of managing security across so many applications becomes a really, really challenging task, and it's really good, security mindset and people and constant 24 round-the-clock vigil. So you can imagine the problems that we are up against, and these are not easy challenges to solve. So that's why I've got the picture of the Rubik cube there, which I could never solve it. It's impossible. So anyway, so moving on. So what was the secret sauce? I guess as of now, for the last 12 months or so, what we looked at was microservices and Kubernetes being the silver lining, which provided us some sort of optimism around how we could solve some of these problems. So what we did was we deployed a very large Kubernetes cluster or multiple clusters, and we also started refactoring our applications into microservices. Let's talk a little bit about the architecture. So I'm just trying to make it really simple to understand. Sorry, I've got the right slides on. Yes. Sorry, guys. Yeah. So I've got a picture of a container orchestration engine up there. But conceptually, basically, we have a bunch of virtual machines that sit on physical infrastructure. And what we basically do, we deployed multiple container clusters on top of those banks of virtual machines. And we put a cluster manager or orchestration engine on top, which basically is Kubernetes. So that's in a very simple way explaining what Kubernetes look like. And the next diagram is basically a slightly detailed look at what Kubernetes is, which basically is a very classic master and node kind of configuration. The master basically does a lot of the orchestration, and the nodes run what are called the pods or the minions, or and you can run microservices within these pods. So that's a very simple way of looking at Kubernetes. There are lots of little moving parts inside Kubernetes. I'm not going to go into the details of those, but I'm sure you can look it up on Google and get yourself educated, or just send me an email or ask Greg. We can answer those questions. So how did we solve our problems using microservices? So some of the problems were very easily solved. Number one was feature delivery. We could, with microservices, we could develop the different features of our applications as independent microservices. Hence, different teams could work on those features, and they could be deployed independently. Which means, for example, if you take digital license as an application, if you wanted to check a license and we wanted to just concentrate on that feature, we could roll that feature out very easily, independently of any other features of the digital license. So that's an example. They're also easier to test. The move to microservices made testing a whole lot easier and simpler and automated. You could implement test automation within the microservices, just test that little feature and deploy it to production. Automation, obviously, automation itself was much easier because we're deploying small chunks of functionality at a time. It was easier to automate and deploy into production. Independent scalability. This was one of the best features. So we could independently allow specific features of microservices to scale up automatically to handle millions of transactions. So think about a scenario where an example application like fuel check. Perhaps one of the most popular features is people want to look up the fuel prices near where they live. So the call to fuel check that looks up, cheap, easy prices near me probably gets, 1,000 times more hits than any other feature. But in a monolithic application, we would have to scale the entire application up. But in microservices, all we would do is basically scale up the microservice that's called find cheap fuel price near me, and that could be, that could run in 1,000 pods and look after millions of people. So that's an example of scaling. The security burden is also sort of reduced a little bit because by moving to microservices, we are reliant a lot on APIs, REST APIs, and securing a bunch of REST APIs in a consistent standard way is an easier way to sort of deploy security compared to trying to secure Windows machines, virtual machines, the complexity around it. And the other benefit we obviously received was the multiple speed organization with independent autonomous teams. Now teams are not getting blocked by each other. They're working on features in parallel and they're deploying in parallel, and everyone's moving quickly, workflows smoothly. Kubernetes obviously is the big driver behind, or big enabler behind microservices. Some of the advantages that Kubernetes also brought was addressing VM sprawl. By moving applications to Kubernetes, we were actually able to cut down the number of virtual machines. Application isolation, the different applications are not running on the same VMs, they were running on different pods, and they were actually not trading on each other's toes. So that was another advantage, and it simplified, management of applications in production and operations as a whole. Availability, having geographically distributed scaled services, microservices, generally improve the availability of our application, and not just applications, also features. Then the other thing was the portability between clouds. I think I've already talked about the security. The portability between clouds. Now, one of the great advantages of Kubernetes is we can have Kubernetes clusters running within your data center or in Amazon or in Google, wherever you want. And if you wanted to port a microservice or a pod from one cluster to another cluster, it's really, really easy. So it allows you to move applications around and move workloads around very easily. So that was, I guess, one of the other sort of advantages. So far, we can see the benefits, and we believe, as a whole, organizations that adopt microservices and Kubernetes are probably on the right track, if they're doing lots of serious digital work. So what's the flip side? What are the lessons learned? So now let me talk about, what we need to think about when we want to deploy microservices and Kubernetes. So number one, we need DevOps skills. Having good DevOps engineers is mandatory. You cannot make this journey without good DevOps. So if you haven't got engineers, start hiring now. If you have good engineers, hold on to them because they are really precious. And the second thing is microservices and Kubernetes is a particular way of thinking and operating. As a developer, you'll need to unlearn a few things before starting this journey. Things like test-driven development, DevOps automation, etc. are very important. The old ways of separating development and support teams doesn't work anymore. They will soon become major bottlenecks. So that's something you need to seriously think about. The other lesson we learned is monitoring is key. Large numbers of microservices mean you need good end-to-end automated monitoring and alerting. And so investing in good monitoring is very, very important. And most importantly, as an organization, you need to make a commitment to microservices. Once you start the journey, you'll soon discover the need to change current ways of designing, developing, and managing applications. This will also result in changes to the ways of working, and the impact won't be limited to technology alone. That is really the main learning I want to share with you today. And thank you for your time again and the opportunity.
Thank you, Raul. That was awesome. Just to finish off before I hand back to Brian, a couple of quick references for people to go and find out some more information. This is the landscape of the Cloud Native Computing Foundation, or CNCF. It's a massively growing ecosystem for containers, and it kind of gives an idea of all of the players in this space where you can go and find products to help you, be that open sourced or commercial. It's a really interesting place to go and have a look. So go and have a look at landscape.cncf.io for further information. And lastly, a really clever and a little tongue-in-cheek guide to Kubernetes is available from DS. They were purchased by Microsoft last year. It's available as a book from Microsoft and also available at this URL, ds.com/blog 2016 Kubernetes Illustrated Guide, and gives a good high-level overview of what Kubernetes is, as well as a quick introduction to containers at the start. Back to you, Brian.
Hey, my shout out to you, Rahul, as a constituent of New South Wales. I love your work, mate. And I admit that I was an early adopter and still am a user of the first digital fishing license.
That's awesome.
There's no poaching where I come from, Rahul. I also understand with the fuel check that the minister had to make changes to the law to force the petrol companies to provide you with the price data. There's not too many people that can say that they were influence had on legislation in this state. So at this point, we're going to take some questions from the audience. I've got the first question now, and I think it's to Rahul. Did you build new applications using microservices, or did you unpack monolithic apps and converting components or functions to microservices, Rahul?
It's a very, very, very interesting question. Yes, I think we have done both. Admittedly, it depends on the situation. We had an opportunity for a new sort of a build where we had to reimagine a new application, and we built it all from ground up using microservices. But we've also started looking at monolithic services and trying to break them apart. I think the key is if you wanted to break down monolithic services into microservices, the key is how how well they're written, if the features are sort of designed, well, so that they can be separated out, that lend themselves to microservices very easily. Also, sometimes when and this is a learning, when you're making a journey and you're quickly iterating a solution, it may not always be easy to start with microservices straight away. You may want to start with a little monolith and then break it down into microservices. But the key to that is making your code refactorable, making sure you write code in a way that you can easily separate later. So hopefully that answers the question.
Thanks, Rahul. I have another question. I think it's to Greg. Hi, Greg. Can you explain a bit more about containerisation, how it reduces the attack surface of an application?
So it might not reduce the attack surface of the application itself, but the idea when you're trying to get into a site is potentially not that actual application, it's the data behind it, right? And you're trying to exfiltrate that data out so that you can sell it for money, right? It's ultimately monetary gain there. So because a container is an isolated unit of work where it's just got that application running, you haven't got a lot of supporting pieces. So a traditional operating system, might come with a compiler, might come with some interpreted language, like Perl or Python or Ruby or something like that installed to support, some of the operating system components, etc. But inside a container, you don't really need these, particularly if you've got something that's, Java or a Java binary. So you're being able to limit your attack vector in that way. So while someone might be able to get into your application, potentially, if there's a vulnerability there, they're not going to be able to get any further. They're not going to have any tools to be able to get any further into your data center and exfiltrate that data out. Also, because if you get to the point of running your microservices, you're not going to be storing state inside that container. And so at that point in time in your evolution going on with microservices from your monolith, you can now actually mount your containers, read-only, which now provides you, nowhere for that person to actually put any tools onto the file system to be able to exfiltrate that data out. Hope that answered the question.
Okay, another question. I'm not too sure who this is to, but I'll fire it at both of you. What is TDD?
So TDD is basically test-driven development, basically, which means when you have a product team writing code, the engineers are writing the test scripts before even they start coding. So that basically means when you start coding, you're testing your code as you go along, and you actually don't need a test team. So engineers do everything. So that's TDD.
Stay online, Rahul. I think this is to you, and it's a curly one. There's some more information about the learning of what needs to change in the project management space, the move to agile, etc. But no, we won't take up 24 hours on this. Just a quick.
That's right. I can probably talk all day about this, and this is very dear to my heart, and quite passionate about it. And perhaps we could probably take your contact and offline have a chat about this. But in summary, agile is the way to go, very often we pretend we know all the requirements of the customer. So there are three things that I talk about: lean, agile, and design thinking. And the three needs to come together to be able to solve the problems that we need to solve for the customer. And adopting the three practices is absolutely essential. So, but perhaps we could take this offline and we could have a chat.
That's cool. Okay, I think that we've got all our questions covered. No, we've got a late entry. Hi, can Kubernetes be used with cloud-based app services like Elastic Beanstalk? I think that's a Greg.
It kind of depends on what you mean by used with. Kubernetes could be deployed beside Elastic Beanstalk, for example. But you would be running one application inside of Elastic Beanstalk, more of a monolithic application, unless you're using something like the multi-container Elastic Beanstalk offering, which is really almost another orchestration engine that's a little bit different and a bit opinionated compared to Kubernetes. So it sits in a similar place. If you're thinking about things like Elasticache, like Memcache and Redis, or relational databases, and in AWS you might have RDS, then definitely you want to be making sure that you're utilizing all of these things, because that's where you want to be able to store your state, and you want to get that off your containers, off your microservices, and off your core cluster and onto these managed services where possible. Hopefully that answers it.
Okay, thanks, Greg. Right, we'll close the Q&A session now. We don't have any more questions. Thanks to Rahul and Greg for your contributions and key insights into the fascinating world of containers. So to round out and summarize the webinar, the key takeaway points for our audience are: containers, microservices, Kubernetes are real and practical technologies that can be deployed and developed right now. The key points to benefits are: number one, it improves security because it reduces the amount of data that can be exfiltrated. It enhances and enables portability of software to achieve the real write once, run anywhere mantra. Number three, it reduces product time to market by shrinking the software package, enabling continuous release and automation. These technologies also enable the reduction in test effort because of the smaller packages are easier to test. They absolutely are made for the hypercloud. There will be reductions in costs of vulnerability patching, and finally, these technologies create an abstraction from the infrastructure layer, which increases flexibility for software developers. Okay, thank you for our audience for joining today and participating through the Q&A. And on behalf of AC3 Bulletproof, farewell and have a great afternoon. Thank you.
I'll just say a quick thank you as well from PSN. So thank you to Brian, also reiterating thanks to Rahul and Greg as well, and for today, and thank you all for attending. Just to note as well, all of this recording as well as the slides will be made available to the audience as well as your colleagues. So it's at publicsectornetwork.co. You can download those for free and sign up for free. And we hope to see you at the New South Wales Digital Marketplace event on the 13th of September at Royal Randwick, where AC3 and Bulletproof will be, and hopefully Rahul as well. Thank you again.